So now we move on to trunking configuration. As you see in our diagram here, in our topology on Packet Tracer, switch 1, where I'm hovering my mouse right now, switch 2, switch 3, and switch 4. So the top left switch is switch 1. The top right switch is switch 3. The bottom left between these 4 switches is switch 2, and the bottom right is switch 4. It's kind of hard to see switch 1 and 2 since the links are covering the names. I'm going to configure trunking on switch 1, port 1, and switch 2, port 1. If I hover my mouse over these, and again, it's kind of hard to see because it gets too cluttered, switch 1, port 1 is connected to switch 2, port 1. Switch 1, port 2 is connected to switch 2, port 2. Switch 1, port 3 is connected to switch 3, port 3. And this one's a little bit clearer, as you see. Switch 1, F0/3 is connected to switch 2, F0/3. That would be fast Ethernet 0/3. And switch 1, port 4 is connected to switch 3, port 4. So all 4 switches are connected to another switch on port 1, 2, 3, 4. So just for ease and not to make it too complicated, I am going to configure trunking on switch 1, port 1, and the other end of the link, which is switch 2, port 1. So I'm going to go ahead and log into switch 1, maximize this. And we are inside of switch 1. And our switch has a name because at the end of the day I saved my configs. So when I restarted the lab, our work from yesterday is saved. I say configure terminal to go into config mode. If you remember, this is where we do all our configs from. Next, I need to make changes to port 1 on switch 1, because that's going to be a trunk, since it is connected to port 1 on switch 2. So the rule in Cisco, to make changes to a port, you have to first go inside of the port. Say interface fast Ethernet 0/1. And you see that our prompt changed here to config if, which means I am inside of interface fast Ethernet 0/1. Now, before we manually configure trunking, and there is a way to manually set trunking, I am going to use dynamic trunking protocol to auto-negotiate trunking. So if I do the command do show interface fast Ethernet 0/1 followed by the keyword switch port, you see that by default this port is in DTP dynamic auto mode. So the switch we are using right now is a 3560 switch. And if you remember, I said that all ports on switches that end with the number 60 have all their ports. So switches that have the number 60 as their model number, as the last number, and this is a 3560 switch, have all their ports by default in dynamic auto mode. So this side on switch 1, port 1, is in dynamic auto. The other side, switch 2, port 1, it's a similar switch. It is also a 3560. That port is also in dynamic auto. So by default, if two sides are trying to talk to each other and both sides are dynamic auto, the trunk will not automatically go up. So if I do the command do show interface trunk, you will see that I don't see anything. Now, if you remember from our lecture on dynamic trunking protocol, if one side is dynamic desirable and the other side is dynamic auto, the port will be turned into a trunk. So I'm going to say switch port mode, and if I execute the question mark or the help feature, you see the word dynamic. One of the options is access, the other option is dynamic, and the third option is trunk. When we created access ports that only carry one VLAN, we use this access option. We said switch port mode access. Now I'm going to use the dynamic option. So I say switch port mode dynamic. And now I have two options, auto or desirable. This port F0/1 on switch 1 is by default in dynamic auto mode. The other side on switch 2, port 1, is also in dynamic auto mode. So I need to turn this into a dynamic desirable port to bring up the trunk. So I execute the command switch port mode dynamic desirable and hit enter. And you see some logging messages appear immediately on the switch. And it says line protocol on interface fast Ethernet 01 changed to up. And then it went back down, but then it went back up. It sometimes does that. The port bounces back and forth a few times before it steadies itself. Now let's see if we have a trunk. Do show interface trunk. And here we go. Now, port F0/1 says status trunking. The mode says auto. Actually, this should say desirable. This is an error inside of Packet Tracer. So whoever programmed the simulator made an error, and the mode still says auto, although it should say desirable. The encapsulation type says N-802.1Q. The N stands for negotiated. So DTP was used between switch 1, port 1, and switch 2, port 1 to negotiate a trunking protocol. Remember, we have two trunking protocols. One is inter-switch link, which is Cisco proprietary, and the other one, the open standard, is IEEE 802.1Q. So switch 1 and switch 2 negotiated and picked 802.1Q as their trunking protocol. The N stands for negotiated. The status is trunking, and the native VLAN by default is VLAN 1. If you remember, the native VLAN of a .1Q trunk is the VLAN that grows across the trunk untagged. So this is the VLAN that the switch does not add a tag or an identifier to. The VLANs that are allowed on the trunk by default, well, this switch can have a total of 1,005 VLANs. So by default, all VLANs are allowed over the trunk. That could be a test question. Once again, by default, all VLANs are allowed on a trunk. Now, let's go look at switch 2 and see if we have a trunk up on that side too, which we should. So I'm going to go ahead and log into switch 2, go to config mode by executing configure terminal, and say do show interface trunk. Again, we see that fast Ethernet 01 on switch 2 has mode by default set to auto, and this is correct. The encapsulation was negotiated to 802.1Q, and the status is trunking. The native VLAN, once again, is VLAN 1, and all VLANs are allowed on the trunk by default. Going to hop back to switch 1. You see the prompt change to switch 1 from switch 2. Now, the next thing I'm going to do is I'm going to modify the VLANs allowed list. You don't want to leave all your VLANs open like this, allowed over the trunk, because it is a security risk. So I'm going to execute the command switch port trunk allowed VLAN, And now I can create a list of allowed VLANs for the trunk. Now, by default, we only had VLAN 1 on the switch to start off with. And then we created VLAN 150. So I'm going to allow VLAN 1, comma, VLAN 150. And let's just say we had VLAN 200 through 220. So I'm going to allow VLANs 200 through 220 also over the trunk. I'm doing this just to show you that you have the option of allowing single VLANs separated by a comma or a range of VLANs separated by a hyphen. So the VLANs allowed over the trunk now will be VLAN 1, VLAN 150, and 200 through 220. Let's see if that list has changed when we look at our trunk again. So I will execute the command do show interface trunk one more time, and you see that the VLANs allowed on the trunk list has been modified to VLAN 1, 150, and 200 through 220. Next, I'm going to change the native VLAN on the trunk to VLAN 150. So I'm going to say switch port trunk native VLAN 150. Since I've changed the native VLAN from 1 to 150, now VLAN 150 will be the VLAN that goes over the trunk untagged. So switch 1 will never add a tag to VLAN 150 when it traverses the trunk link as long as VLAN 150 is native. Let's see if we actually, this change took effect. And if you see, my native VLAN has changed from VLAN 150 to from VLAN 1 to VLAN 150. Now, if we wait a little bit, we will see that the switch will start complaining that there is a native VLAN mismatch. So I'm going to leave switch, here we go. I thought I would have to wait longer, but here we go. So CDP is a protocol that runs between Cisco devices by default automatically. We haven't covered CDP yet, but this protocol CDP is reporting that the native VLAN on the other end of the link, which is switch 2 port 1, is still VLAN 1, and the native VLAN on this end of the link is VLAN 150. So to stop the switch from complaining every now and then, we have to go to switch 2. I switched over to switch 2, if you notice. And switch 2 is also complaining that the other end is VLAN 150 and I'm VLAN 1 as my native VLAN. So we're going to switch over the native VLAN to VLAN 150 on this end. So first I go into the interface, fast Ethernet 0/1, and then I say same command, switch port trunk allowed VLAN, switch port trunk native VLAN 150. Let's check to make sure that the VLAN has changed over, the native VLAN has switched over to 150, and yes, it has. It is always a good idea to keep commands consistent on both ends of a trunk link. So on switch 1, we had modified the VLANs allowed on trunk list. Let's modify it on switch 2 also. So I'm going to say switch port trunk allowed VLAN 1, 150, then 200 through 220 to keep it consistent with the other end. Now let's look at our trunk again. Do show interface trunk. And I'm shortening interface to INT, which works just fine. And our VLANs allowed on trunk list has been modified. So let's pop back into switch 1. And we are going to look at a little bit more detail for port 1 on switch 1. Do show interface fast Ethernet 0/1 switch port And here actually, there is no mistake. Fast-Ethernet at 0/1 shows that it is in dynamic desirable mode. If we check on the other side, you will see that switch 2, port 1, is in dynamic auto mode. And I'm going to do that in just a minute. You also see that the native VLAN for the .1Q trunk has changed to VLAN 150. And the VLANs enabled over the trunk, or the VLANs allowed over the trunk, are VLAN 150, and 200 through 220. Let's go check the other end. Let's go to switch 2, and I say do show INT, short for interface, fast Ethernet. I'm just going to use the letter F, 0/1, and SW for switch port. So I can shorten the command. This is the same command. It actually says do show interface fast Ethernet 01 switch port. And I'm going to hit enter. And you see that switch 2 port 1 shows as dynamic auto. The native VLAN of the trunk once again matches switch 1, which is 150, and the VLANs allowed over the trunk list also matches switch 1, which is 150, 200, and 220. Now we have seen both the dynamic auto and the dynamic desirable mode between switch 1 and switch 2. What about the last mode? DTP's last mode that it can run in is mode on. So I'm going to switch over to DTP mode on and unconditionally set switch 1 port 1 to trunking. So I execute the command switch port mode trunk. Now let's look at the trunk. Do show interface trunk. Now the mode says on. This is DTP mode on. Before it said dynamic. It should have said dynamic desirable. It said mode auto. That was a mistake in Packet Tracer. But now it says mode on. Let's go ahead and choose mode on switch 2 also. So I'm going to do the same command over. Switch port mode trunk. Now, this command was rejected at this end because the encapsulation type or the DTP mode on this end is set to auto. And the switch is basically telling me that if the mode is set to auto, then you need to manually pick what type of trunking protocol you're going to use over this link. If you don't want to negotiate, you want to just unconditionally set this side to DTP mode on, then you better pick the trunking protocol also, either ISL or .1Q. So let's go ahead and pick .1Q. Switch port, trunk, encapsulation, and if I say space question mark and execute the help feature, the only option we have is .1Q. Nowadays on switches, you don't even get the option of running ISL. Why not? Because ISL carries with it too much overhead. And ISL encapsulates the original frame in a 26-byte header and a 4-byte footer. That's 30 extra bytes. .1Q simply inserts a 4-byte tag into the original frame. So that's less overhead. Nowadays, actually, this command won't even be available on the switches because the switch will automatically pick .1Q. The reason this command exists in Packet Tracer still is because this command is part of the CCNA course. So Packet Tracer is supposed to be a learning tool, hence this command still exists in Packet Tracer. So I'm going to say switch port trunk encapsulation .1Q and hit enter. Now let's look at our trunk again. So do show interface trunk. I'm simply scrolling through my command history using the up and down arrow keys, so I don't have to type them over again. actually, this should have changed over. This N should have disappeared. Let me go ahead and manually set the encapsulation type on switch 1 also. Switch port, trunk, encapsulation, .1Q. And now look at our trunk, do show interface trunk. And you see that the encapsulation type now does not have an N in front of it. That is because now you are not negotiating the encapsulation. You are simply manually setting the encapsulation to .1Q. This should have changed over on switch 2 also now. Let's bounce the port by shutting it down and bringing it back up. So I simply executed the shut command and no shutdown command to bring it back up. And now let's look at our trunk. The N still has not disappeared on this end, and it really should. So switch port, mode, trunk. Let's manually set the trunking to, just manually set the trunking to trunk, set the port to trunk, or DTP mode on. And now let's look at our trunk again. Okay, that seemed to have worked. The mode for the trunking is on, and the encapsulation is .1Q without an N in front of it. That means you are not negotiating this trunking at this point anymore. Now, I'm going to ask myself a question and answer it. Since we are not negotiating trunking, we are not negotiating our trunking protocol, I'm not asking the other end, hey, what protocol between ISL and .1Q would you like to use? I have manually set it to .1Q with the command switch port trunk encapsulation .1Q. I have manually set the trunking encapsulation. So I'm not negotiating that. I'm not negotiating whether I want to be a trunk or not. I have simply set the mode to DTP on, or unconditionally set this port to trunking. Do I really need DTP at this point? Or am I still running DTP at this point? Let's find out. Do show interface fast Ethernet 0/1 switch port. And if I look, my administrative trunking encapsulation is .1Q. My operational mode is trunk. My administrative mode is trunk. However, if I look at negotiation of trunking, it's still on, which means I'm still sending DTP frames back and forth between switch 1 port 1 and switch 2 port 1. That should not be the case because I'm using up bandwidth sending frames that I have no need for at this point. So let's turn off DTP at this point. On switch 2, I'm going to do the command switch port no negotiate. So I don't want to negotiate trunking with the other end at this point. Also, on switch 1, I'm going to go execute the same command. Switch port, no negotiate. Now, let's check on both sides. So let's go to switch 2 first and see if I have turned off DTP. And now, if I look at negotiation of trunking, it says off. Because I don't need to send DTP frames across the link anyways. So I'm just wasting bandwidth if I'm sending frames that I don't need. So I turned negotiation off. Or I turned DTP off. Let's check on switch 1 also. Going to flip to switch 1. Do show interface fast Ethernet 0/1 switch port. And also on this side, I see that negotiation of trunking is off. Let's look at our show run or show running config. Remember, that is stored in RAM, and this is our current configuration, the current changes that we have made. We haven't saved these yet. So let's look at them. Do show running dash or hyphen config. and scroll down to port 1, and you see all the commands that we did are here. Now, are these saved to our startup config? Let's look at our startup config. Do show start. If I look at my startup config, you don't see anything under port 1 because we haven't saved these configs yet. So let's save them. Remember, our save command is copy running config, which is our source file, to startup config, which is our destination file. I hit enter, and it's asking me, are you sure you want to do this? And I hit enter again, and it says building configuration. Now let's look at our startup config again. Show startup config, and we should see all our configs sitting here, and we do. This concludes the trunking configuration part of the lecture. I am going to take a moment, since it will be redundant for you to sit here and watch me do all 4 of these switches, but switch 1, 2, 3, and 4, port 1, 2, 3, and 4, I'm going to execute the same commands that we just did on switch 1 and switch 2 over and over again. Okay, folks, I have gone ahead and configured port 1, 2, 3, and 4 on each switch into a trunk. So I just want to show you that they have been configured. Show interface trunk. And as you see, port 1, 2, 3, and 4 are all in mode on, which is DTP mode on, which is unconditionally set this side to trunking. And the trunk type is 802.1q. Status is trunking, and the native VLAN has been changed for all ports to 150. That is switch 1. Let's look at switch 2. Switch 2, maximize, show interface trunk. Once again, you see port 1, 2, 3, and 4 are trunks. Let's check switch 3. Once again, show interfaces trunk. And we have 4 trunks on switch 3. Moving on to switch 4. As I said, always check your work and verify that the changes you have made have applied before moving on to your next job. Show interfaces trunk. And once again on switch 4, we have port 1, 2, 3, and 4 that are trunking.